Welcome students. Today we will discuss about how to solve sphere optimization problem and raster optimization problem using Tabu Search Algorithm. So the formula for sphere and raster optimization problem is given here, and the implementation for this objective function is already discussed. So let us see directly implement. So you need to understand in this program also our Tabu search algorithm, it will generates only the binary values, but here you can see x is a real value or integer values only. So you need to convert the binary values into integer values. So just like this, just like in our previous video, you need to perform this. So let us first we will see the sphere optimization problem. So we already discussed the Tabu search algorithm, and the syntax for this function is given here. So you need to initialize all these arguments. First one is the size, that means total length of the binary solution. So and then iteration, this is what is the maximum number of iterations you need to perform. So next one is objective function. So here in this case the sphere function you need to pass. Actually here we cannot pass the sphere function directly because sphere function is originally implemented for integer values. So we have to convert the binary into integer values, and then the config, which is the initial solution. Okay, what is the initial solution? From where we have to start, that we have to initialize. It is a vector of size this size. Okay, and then how many neighbors has to be considered, for that you have to specify in terms of values, and then this is the memory size. So finally it will, the Tabu search algorithm will output the list. Okay, list object. In this list object we have elements, config element and then utility key. So config key, you will have all the matrix with stored solutions. Okay, config with stored solutions, and then the vector and its corresponding evaluated values. So let us see directly. So you use the library, Tabu search library, and then use the sphere function which we have implemented here earlier. You can see the syntax. For this function we are implementing like this, and then so actually our problem is, I think d is not given, so you can take the d variable. So 5 variables are there, the dimension is 5. So let us say, for example, I want to find out the range. Here in our problem the range is not specified, so let us take the range as maximum values a variable can take is 1000. So if that is the case, you need minimum 10 bits to store the value 1000. So okay, the formula for calculating this maximum bits required to store the 1000 value is you apply the log function to the base 2 and then apply the ceiling function. So you will get the total number of bits. So for 1000 you will get 10 bits are required. Okay. For storing 1000 values you need 10 bits. So total, since we are having 5 variables, the dimension is 5. So 5 into 10. So this is the total size of the bits. So you take the sample function. You take the sample function. You take the sample function, and then what you say, initialize the s value, and then what you are doing is you call this function. So you specify the size, total number of size, and you can keep the number of iterations, maximum number of iterations 200, and specify the objective function. Here you cannot directly give this function, sphere function. This function it will process the integer values. So x is a vector of integer values. Here you can see this. So you need to convert the binary to integer. For that we are using this function. So x takes here binary values, and then we are calling this function to convert binary into the set of d prices, d variables, integer values. So the explanation is already given for this in the previous video. So since we are generating a strings of ones and zeros, it may cost the maximum range also. So if that is the case, you penalize, the FE should be minus infinity. So if the generated value, that is integer value, yes, is less than maximum range, then you can call this function sphere function. Now the values are evaluated. Okay. So you call this function here. You have to pass here this function, and then the config. This is the initial solution which we took with the help of. Or you want to initialize. You can also initialize origin also. You can start from origin also. In that case, S is equal to, you define a column vector of 0, 0, 0 of dimension size. Okay, that also you can do. Okay, and then the number of neighbors you have to consider for each solution. How many neighbors has to be considered, because if here we have specified neighbors as 4, means 4 neighbors are considered. After that, best neighbor is 1 is chosen. Okay, and then finally this is the memory size. So to hold the 16 recent solutions. So you can also change this. So once you call this, it will throw the output list object. So with this, you can easily calculate. I want to find out the maximum. So you want to find out minimum also. You can replace max with min function. So you will get the index. So this function, it will throw you the index, best index. Once you got the index, you can get, you can use with the help of binary to integer function, that is this function. So to convert into the integer vector. Okay. So you can change this also, max min. If you want minimization, you can also change this. Okay. So it's very simple. You can change this one also. You can change and see how it looks like. Okay. If you want, you can change this also. Not a problem. This is just an index position. Okay. So let us execute. So this is the maximum value we are getting. So at this value we are getting the max value. So this is the optimum solution for size 5, 1, 2, 3, 4, 5. Okay. Now I want to find the minimum value. You just execute the two statements. So minimum value is 0. So at this you are getting the minimum value. Okay. So with this you can execute the function. Okay. This is about sphere problem. So once again you can also run. So you can see the maximum value and its corresponding best solution. Okay. This is the initial solution. Okay. Initial solution, yes. So depending upon the initial solution, our best solution will change. Okay. If you put 0, 0, 0, you may get different solution. Okay. So like this you have to analyze. You can save this file. Thank you, students.